Okay, so if we want to do number 10 in 20.1, which is compute the curl of f of r is r over mag r. Where do I even start with this? Like, what do I need off the bat?
Preferably what R equals.
Yeah, I think I have no idea what r is.
Yeah.
So,
For
what's the book usually use r for? Like, what do they mean by r? It's like, basically, I'm like, hey, dude, I know how to compute a curl where there's f of x, y, and z, right?
Mm-hmm.
And this thing doesn't have an x, y, and z, so what the heck? You guys remember the book has a standard definition for this r thing? It is not x squared plus y squared, because it has this little vector hat. Their standard definition for it is that r of x, y, and z is x, comma y, comma z. Right, so why do they call this thing r?
It's just a radial.
Right, so if you have your kind of usual axes, right, and you have a like point up here, the vector that goes from 0, 0, 0, right, from the origin up to that point
It's X, Y, Z.
is x, comma y, comma z, right? But this is a little bit like the row in spherical, right? You guys see that? So that's why they're thinking about this thing as r. They're like, that's whatever the vector version of a radius is from 0 up to that point. Cool, cool? So this is just a thing about like standard notation in your book. And now, once I think we know this, maybe we can figure out what f is in terms of x, y, and z, and then we can actually calculate the curl.
I was going to say, if R is just X, Y, and Z, don't we kind of know from just observance that that's going to have a curl of the zero vector? Like, I mean, we could plug it in and figure out, but.
Yeah, so keep in mind that I'm kind of drawing this, right?
Mhm.
But the vector field here, right, is based out here at this point. Right, so this vector field f that I'm talking about, right, is actually based here and points this way. And they're all divided by the magnitude. So
They're all just fine.
this is kind of vectors all of unit length pointing out from the origin, right? You guys all see that? So I could think to myself, like, if we just had this kind of explosion going, where would there be curling? It seems like there probably wouldn't be, right? You guys see that? So let's check. Let's see if our intuition holds. Maybe it will. That'd be great. So what's my f then? F in terms of x, y, and z?
X, I, Y, J.
So it's like, oh gosh.
But I'm dividing by the magnitudes, right?
Oh gosh.
You guys remember this thing from, we did a very similar problem the other day.
Hmm.
Right, so we have x over x squared plus y squared plus
Z squared, the square root of that.
z squared, all square rooted.
Mm-hmm.
So that's my first component.
And Y
My second component is y
over that.
over that,
Yeah.
x squared, y squared, z squared to the 1/2, and then z over the same thing, right? Oops, all to the 1/2. Okay, and now I need to compute a, what?
You need to compute the
Yeah, I need a
gradient cross
curl,
with
right? Yeah. So, all right. So let me quick maybe over here. Right. I, J, K. And then what's your, so how do you get a curl?
Yeah, it's partial of x. It's gradient,
So you
basically.
take the idea of a gradient, right? Partial with respect to x, partial with respect to y, partial with respect to z.
And cross it with f, which is
And
x.
yeah, so then you need to cross it with f, right? And so I'm going to call these things, I'm going to call these Bill X, Billy, and Bills, because that was fun last time.
And in every bill, there is a Steve.
Okay? Yeah, and then probably we're going to end up with a bunch of this like weird stuff that cancels, right? Okay, so why am I doing this kind of shorthand here?
Because it's a lot to write.
Yeah, this is just going to be a bunch of calculation, right? So I'm trying to like slim this down into manageable pieces because I don't do well with giant frigging calculations, right? So I'm going to first write down this in terms of which partials I have to take of what, and then we'll go over to the side and take a bunch of partials. You guys all good with that? What's up, Ken?
If we write bills on our test, would you mark that down?
No, not at all. You're allowed your own name and convention. Like, that's part of what I'm trying to illustrate with this stupid name. It's just like, yeah, whatever, call it something. Like, it helps if that something is meaningful to you, right? So, like, if there's a gravitational field, what are you going to call it? Probably not smiley face, right? But, like, G might be a good idea, right? If it's a gravitational field due to some object, you might like name the gravitational field after the object, right? Like you're allowed some latitude in naming. So what do I get here? How do you do a curl? Yeah, take
Bill
this cross
Z,
product.
partial.
So I need the partial with respect to y of Bill Z minus,
the partial with respect to z of Bill y.
that's Billy then.
Oh, sorry.
Don't be rude.
Tell me ridiculous.
Alright.
Okay, so then I got comma, what's your,
Partial with respect to z of Bill x. I do it backwards
Okay,
to take
good.
out the minus.
so to deal with the minus, we're doing partial z Bill x minus
With
partial
respect to x of Bill z.
x Bill z. No, that's Bills. Jeez, dude.
Gosh, I'm sorry.
Double Z.
I know, I said it down. It's Bill.
It's partial with respect to x of Billy.
Okay. Partial with respect to x of
Billy.
Billy.
Minus partial with respect to y of Billix. Of Bill.
Partial
Bill
with
x.
respect to y of
Bill x.
Bills. Bilks? Billix?
Yeah.
Whatever.
Yeah, it's Skrillex's cousin.
You guys cool with this? So I got all these little bits and bobs I gotta do, right? Okay, so some of them are gonna be, let's see, actually, go through and check this out, right? So be like, all right, so here I'm gonna take the y partial of something that's the z one, right? Here I've got the z partial of the y one. Here I've got the z partial of the x one and the x partial of the z one. And then the x partial of the y one and the y partial of the x one. You guys notice something special there?
When you're finding x, you use z and y. When you find y, you're using x and z. When you find z, you use x and y.
You guys see that? They never match,
Yep.
right? So I'm never taking a partial with respect to x of the Bill x piece, right? So I think I can probably just figure out how one of these works, and then maybe I can save myself some time. You guys see that? So which one do you want to start with first?
Just do partial of y to Bill's.
Sure.
And
So we should take the partial with respect to y of Bill's, and Bill's is z over x squared plus y squared plus z squared all to the 1/2.
Yep.
Right?
so, yeah, the
Okay,
partial-
and Manya at this point would be pointing out that, do I need the quotient rule?
No,
No, don't use the quotient rule specifically on this one, why wouldn't I use the quotient rule? Like, one, it sucks.
Okay.
Here specifically it sucks because the top, what? What's special about the top of it? Yeah, it doesn't depend on y, right?
Oh my gosh, duh.
So the quotient rule would be major overkill anyway,
Okay.
right? So really I'm thinking about this as the partial with respect to y of z, which is constant.
Yep.
So I've got, and then I've got x squared plus y squared plus z squared, all to the minus 1/2 power, right?
Okay.
Okay, so when I actually do that partial, I get z,
Yeah, it's
Negative 1/2 y.
negative 1/2,
And then x squared, y squared, z squared to the
x squared, y squared, z squared, right?
to the negative 3/2
To the negative 3/2 times
to y.
2y.
So it's negative.
It's just zy times
You guys
that
good?
y.
So I got zy, well, minus zy, right? Over x squared plus y squared plus z squared to the 3/2 power. You guys see that?
Mhm.
Okay, so let me develop a theory here quick. Because I'm going to have to do a whole bunch of these, right?
Yeah, too many.
Like, so I think my theory is when you take the y partial of the z thing,
Yep.
right? I got the z thing,
Yep. And the y.
right? Like,
Yep.
most of this is just a z thing with a slightly different power in it, right?
Yep.
Like, that's basically the z thing,
Yeah. Times negative.
except for this.
Yep.
So I need to make sure that I remember that the power changed in there.
Yep. But the
And then I
power's gonna
got-
change the same for every single one.
Yeah,
so.
the power change will all be the same, right?
Mhm.
And then I got the variable I was differentiating with respect to,
And then a negative sign.
and a negative sign. Okay. So what I'm going to get out of this is, oh god.
So we can have that for Billy to the partial of z, that's
Oh, did I write? Oh, I wrote something totally nuts here earlier. I had f was stuff, and then I wrote equals, and I started calculating the curl, right? So what I meant here was, this is actually the curl of f that I'm doing.
okay.
Those two things weren't actually equal. Sorry, shit notation on my part. My bad. Two numeric. Okay, so I got out of this, right? So I got a minus zy over x squared plus y squared plus z squared to the 3/2, right?
Mm-hmm.
And then what are you going to get out of this other one?
Minus yz, so basically another minus zy. And then
Yeah, let's maybe write this carefully for this one at least.
yeah.
So we got a yz, right?
Of x squared plus y squared plus z squared to the 3/2.
Oh,
Yeah.
and those
Cancel.
cancel. Cool. So 0, comma. All right, so this one's going to have a zx thing, right? So that's going to be like minus xz over some crap, minus
zx, negative zx.
negative zx
Of some
over the
garbage.
same crap, right?
Oh, that's another 0.
So that piece is going to 0 out again, and then your next one is
It's going to be 0 again,
also 0. So you got what? That the curl was
the 0 vector.
very nice.
A lot of work.
Thank you for getting the right category of answer. You guys all see that?
Yeah.
It's the 0 vector, right? In the end. So what does that tell you?
They're,
That this kind of explodey vector field, right? That's unit length everywhere. Like all it does is point out at unit length.
It doesn't spot.
Has 0 curl.
It just always goes outwards. It doesn't spot.
Yeah, there's no little local eddies in there, right? You guys see that's what those little curl things are measuring? They're measuring like, hey, if this was a river, are there any little eddies? You guys know what an eddy is, right? Anyone willing to admit they don't know what an eddy is?
I admit that I don't know what it is.
So an eddy is where the, okay. So here's a river, right?
Where water gets stuck.
Okay, put a rock in your river,
Okay.
right? And then think about the way the water flows around your rock. It goes like this, right?
And then there'll be that one
What's that?
spot where it can't move.
And then on the back side here, there's this kind of funky hole thing, right? You guys see that?
Gets stuck.
So that thing makes an eddy, right? So on this guy, there's two little eddies that kind of cancel each other right next to one another. That's the hole behind a rock. If you have a rock that sticks out from shore, like this guy, right? There's a little bit of this action going on there. There's a little spot that'll circulate. This is where those big like rafts of foam build up in whitewater. This is also where we look for bodies or trolling the sides of rivers. Because that's where stuff ends up, right? It gets sucked out in the eddy, and then it just chills there, and it won't get back in the current very often. So this is also useful when you're swimming in whitewater, which you should never be, right? But if you happen to be swimming in whitewater, if you see a big raft of foam on the side, go that way. Because once you're in that, it's like from being in a river to being in this like lazy river thing, like the lazy river ride. Like it goes from being scary whitewater to being like, oh, I'm just floating in a circle pleasantly. How nice. Cool, cool.
The problem is getting into that.